So I know that, like anything else, you could use photomath, right? So any of these problems, you can use photomath. You can cheat your way through it, and I'm just encouraging you not to and resist that urge. So um, don't do it. Just think of this as a puzzle, and use the rules to solve it. So I got about 4 properties that we're going to do, and we're going to either use the condensed version or the expanded version. So condense to the expand. And you can do this in any order you want, meaning you don't have to use one rule and then not another rule. You can use 2 rules at the same time if you need to. But there's really, I guess there's only 3 rules that I'm gonna go through. The first one is I'm gonna call it the power rule. And the power rule is if you have log base b of x to some power. So if you have that x to the a, we can expand that. The property is that you just drop that power down. You can put that power out in front. So if it's x raised to a power, you can put that up in front. And you can go in either direction on this. The product rule. So the product rule is if you have log base b and you have x times y. So we have something like this. What we can write that is we can write that as log base b of x plus log base b of y. Think about what we did when we had those similar product rule with with the exponents, and we added those exponents. This is the same. This is the log version of that same rule. The last one is the quotient, and that's really division. Okay, and division is if you have log base b and you have x divided by y, you can probably guess that that's log base b of x minus log base b of y. One final note that we haven't really talked about is log base b of b is equal to 1. So if the base matches whatever you're taking it, it's just equal to 1. Now, what we're going to do is we're going to go in either direction. Either we're going to be condensing things or expanding them based on what Delta Math asks us to do. We're going to be asked to do one or the other. I got about 9 examples to run through with you. So we're going to try to run through them relatively quickly, but we're going to run through them. So something like this one, write it as a single logarithm. I got the addition between those two. So if I wanted to, I could write this as log base b of 6 times 2 using that product rule, or log base b of 12. If I multiplied those together, I could just write that as log base b of 12. That's what I'm going to put in right here. I'm going to put in 12. Notice what you have to put in. Take something like this one. Notice what I can do to that too. So I could do this one. I could say this is log base b of 10 to the second power using that power rule. And since it's subtraction in there, I could divide it by 4. Well, 10 to the second power is 100. Divided by 4 is log base b 25. That's what I'm putting right in here. 25. And that's what I'm going to submit for an answer. Okay, condensing it. So now we're going the other way. We're going from an expanded one to a condensed one. What this is this is going to be, think about what this, I'll do it in 2 steps. This is log a to the k power minus log d to the q power. Well, since there's subtraction in there, that's really log a to the k divided by d to the q. That's what I'm putting in here. A to the k divided by d to the q. So I condensed it, just using those same rules that I have. Take something like this one. Now I'm expanding it. So I'm taking it and I'm pulling it apart. Notice that there is, right in here, there's a multiplication in there. So I'm going to do this in 2 steps. If I did this in 2 steps, this would be log x plus log y to the third. But we can pull that, and notice they want it just in log x, log y. I have log y to the third, so this is log x plus 3 log y. And that's what I'm going to put in. Same kind of thing with this one. But if I think about this one, this is really log x squared minus log y cubed. And then I can bring down the 2 in front and the 3 in front using the power rule. So I use the quotient rule, the division rule, and then I use the power rule. And that's what I'm going to put into Delta Math. A little bit more confusing, but remember that this would be the same thing as writing log x, this is y to the 4th, z to the 1/3. So we can do this all at once. We could write this, well, I'll do it in 2 steps actually. We could write this as log x minus log y to the 4th, z to the 1/3. Well, if I wanted to, write this as log x minus log y to the 4th plus log z to the 1/3. Now I'm going to do one more step on this. I'm going to try to space it out here, but I'm going to do one more step. The thing that I'm going to do is I'm going to distribute this negative through to both things in here, and I'm going to bring those powers down. So I'm going to write this as log x minus 4 log y minus 1/3 log z. And that was just because of the subtraction in there that I can put through to both things. Okay? So find the numerical derivative of the numerical value of this. They give you some things up here and they say, okay, well, what do you got here? Well, let's think about what this is. This is log a to the 5th, and all that's to the 1/2, right? Minus log b to the 3rd minus log c to the 2nd. Now I'm going to do a little bit of work on this. I'm just going to do a little bit here. I'm just going to say this is log a to the 5/2 minus 3 log b minus 2 log c. Remember what I can do with this. I can write this as 5/2 log a minus 3 log b minus 2 log c. But now I'm going to use these things that I have. So instead of log a, I'm putting that in there. Instead of log b, I'm going to put it in for all of this. So I got that for all that. And then finally, instead of log c, I'm going to put in 1. So I could write this as 5/2 times -8 minus 3 times negative 5 minus 2 times 1. Now if I do this, if I do the arithmetic on this, this would be negative 20 plus 15 minus 2. Negative 20 plus 15 is negative 5 minus 2 is negative 7. Okay, so I use those values that they gave me on there. Let's take a look at this one. What is the value of 6 log 36? Remember, log base 6 of 36 is equal to some value, whatever that might be. That means, remember that we talked about that this was the power, this is the base, this is the base, this is the power, and this is the other side. So when we talked about this, we could write this as 6 to the x is equal to 36. That means x must be 2 in this case. Same kind of thing on this one. Okay, so only I'm going to do let me think how I want to do this. I want to do this way. 9. So remember, this is log base 9 of 81 to the 1/5. Hopefully you know, remember that that's what we have. So this is 9 to the x is equal to 81 to the 1/5. Well, let's think about what 81 is. 81 is 9 squared, right? I mean, we could write this as 9 squared and then to the 1/5, because 9 times 9 is 81. Well, think about what we have here. This is 9 to the x. This is 9 to the 2/5. If we think about what exponent rules are, that means x has got to be 2/5. So that's the last problem that I'll have you do. Problems like that. Hopefully that makes sense. Go back and review that if you need to. And good luck. Let me know if you need help.